The Ben Heck Show is brought to you by Element 14, the electronic design community and online store built for engineers and hobbyists alike. Join now and browse the store at element14.com.
Benjamin J. Heckendorf. Every week he takes on new projects, shares tips and tricks, and answers your viewer questions on The Ben Heck Show.
Hello and welcome back to The Ben Heck Show. In today's episode, we're going to talk about an important but not often discussed aspect of our projects, the wiring itself. We'll talk about different types of wire and how to use it. Let's get started.
But first, the news.
Today in Ben News, I wanted to show you this cocktail pinball machine. Now, a cocktail game is any arcade machine that fits inside of a cocktail-like table, so you can sit down at it and like drink your martini and play pinball or, Pac-Man or something. The reason I bought this was because I wanted to reskin this game into my own custom theme. More recently, I found another one of those Allied Leisure playfields at a pinball show, and I bought it for a great price and stripped it all down to get the parts. So what I can do is have an extra copy to make my own playfield and make my own custom cocktail game. Cocktails, beer, bars, Roadhouse, the 1989 classic movie. That's going to be my theme, because pain don't hurt. Why are we here? Well, we're going to talk about different types of wires and how to use them. You've seen us use wires a lot of times in the show. I mean, they end up almost in every episode, but we never talk about the wires themselves. So we're going to talk about how to attach wires to things, how to attach wires to other wires, how to cut and mend wire bundles such as USB or HDMI, and how to use things like heat shrink tubing and Molex connectors. We're going to start by talking about just regular wire itself, like hookup wire as it's often called. There's two basic types. There's stranded and solid. Solid is a solid piece of wire, where strand is many small wires stranded together in a cable. We've never really used solid on the show because there's not much use for it on the show. It's cumbersome to use. It's best like in your walls, like AC current that powers your outlets. Those are usually solid wires because they need to be nice and stiff and strong. But yeah, stranded basically, when you strip it, oh, wrong one. You'll see the strands. Of course, you want to twist them together so they are solid like that. You want to make the strands solid. You don't want any stray strands coming off the end. So we're going to start by doing a few wiring examples using the stranded wire. Let's go over some of the basic tools that will be useful when working with wires. We have our standard wire strippers. Although I don't use them that much, I usually just use angle cutters to strip the wires. I'm just used to it that way. These are kind of dull. Got some Molex connectors. These are KK series, 2.54 millimeter pitch, which is 0.1 inches pitch. We'll hook these up to these wires here. Stranded red and black, so we can make like a positive and negative power connection. Also, heat shrink tubing is really useful. Got the sample kit from Newark Element 14. Lots of different sizes. You heat it up and it shrinks over the wires and insulates it for you. So let's do some examples. All right, I'm going to start by hooking up a Molex connector. So let's strip these wires. Again, I just do it by hand. As soon as you strip it, twist the wire. That way you don't have any loose strands. I just use the angle cutters to strip wire because I'm used to it and it's faster for me. I keep these around for when my friends visit. Okay, now these crimpers, if you don't have a crimper, you can still do it by hand. I usually like to pre-tin the solder, or not the solder. I usually try to pre-tin the wire. That's basically where you put solder on the wire before you connect it to something. Makes it much easier later on. Okay, so in the case of these, I don't have a wire crimper, so I'm going to just take my angle cutters here and just kind of crimp it manually, just a little bit. Come on. Okay. I have some wire crimpers laying around, but they're not mine, they're my friends. I need to give them back. And I like to just put a little solder in there, just so you know it's connected, it's not gonna pull out ever. Okay. Give it a second to cool off, because if you move the wire immediately, it might not be cool, which means it'll just, get removed. Got that. I'm gonna do this red one here. Kind of run out of hands pretty quickly when soldering, so see how I'm using my pinky finger? I'm obviously super ambidextrous. Espialidocious. Now these Molex connectors are great because you can use them to have polarized disconnects on your projects. A little bit more solder. So since I only have so many hands, I'm just grabbing a little solder and then bringing it over here. All right. Let that sit for a second. Should be good. Now this is the Molex receptacle, which means these pins go into it. One thing that's important, you remember if you're ordering parts like this, you need to order the receptacle, the plastic header, and the pins. The pins will usually be separate. So if you're ordering something like that from Element 14, remember that, oh, don't forget the pins. See? There's a clip in it which holds it in place and polarizes it, which basically means you can't plug it in backwards. So now on our circuit board, we can hook it right up. There we go. So yeah, it'll stay in place. A little header won't necessarily stay in place because there's no locking mechanism, but this one will. Unless you pull on it really hard, of course. Texas Instruments has released a new ARM-based single-board Linux computer, the BeagleBone Black. TI makes it easy to get started. There's a new micro HDMI port, so you can hook it up to your TV and boot directly to Angstrom Linux, which comes pre-installed in Flash. You can use the SD card slot to install a different distribution of Linux, such as Ubuntu. You can attach it to your computer with a mini USB port, which also powers it. The BeagleBone will serve your PC a web page over the USB cable, allowing you to configure the device and even program it through your web browser. And of course, you can always SSH into it via the Ethernet port. You can get your hands on a free BeagleBone Black by joining the Road Test program at element14.com/road test. In exchange for the test hardware, we ask that you write a blog review of it. This helps other members learn about products and make informed decisions. To learn more about the BeagleBone Black, check out the new single board computers area on the Element 14 community today. For the next example, I'm going to show you extending some wires. I'm going to strip these using my bad method. I could also use my teeth, but I only usually do that on thin ribbon cable. Okay. And I know everyone's thinking, oh, he's got a pair of wire strippers right there. Why doesn't he use them? It's just not how I roll. So this is our heat shrink tubing. We're going to put it on, obviously before we connect these things, just to be, proper. All right, slide that in place. All right, now let's say what we're trying to do is extend this. So we're going to do the Western Union / NASA splice. First we twist these wires to make sure the strands are all in place. You don't want loose strands, especially when you're attaching to a circuit board. Loose strands can cause short circuits. Once we have these twisted, we're going to bend them over a little bit and interlink them like that. See? Now we're going to twist them again on each other. All right. Then we're going to put solder on it. So basically this will be a really good connection. Better than we need here, but I'm just showing you a good way to do it. So yes, they're looped together and wrapped around each other, so now they won't come loose. I guess we could try to break it, but now we just slip the tubing over it. When you pick the size of heat shrink tubing you need to use, remember you don't just have to go over the wire, but you have to go over the interconnected wires, which are going to be thicker than the actual wires because it's two wires connected together. Because you might bring this all the way over here and it might get stuck on there, so always make sure you have enough. We center it over it, and then I just use a lighter, it's faster. Shrink it, there, the heat shrink tubing. I've got a nice professional looking connection. We'll repeat that for the black side. Now that we have the wire the length that we want it, I'll do my favorite trick with help from my assistant Allison. I stick the end in a drill and I braid it. Pretty cool, huh? Using a drill is a quick way to braid up wire. So this will be a nice little power connection for us, black and red, but we should talk about the amount of power you can put through wires right now. Okay, so all this wire is measured in something called American Wire Gauge, or AWG. If you look online, you can find the ratings for each gauge of wire. Here we see 24 gauge wire, like this wire, is rated to 0.577 amps. So you should keep that in mind when you're designing something. Don't put too many amps through too thin of a wire. If you can, use a thicker wire or double up the wires. The The next type of wire we're going to talk about is ribbon cable. Ribbon cable is like regular stranded wire except for it's attached together in a row. Now, a great place to find ribbon cable is from old computers. This looks like it came from a floppy disk. It's really old. We can cut those apart, get free wire. Or if you're making larger things, you can just buy a box of it from Element 14 like this. And then it comes out in predetermined length. And then, you know, it's really great because you can cut it up in little pieces and attach it to things like headers for doing interconnects between boards. You can also use it with Molex. It's more appropriate to use the smaller headers though because of the pitch. And yeah, one thing, you don't really want to transmit power with this type of ribbon cable. Again, it depends on the American wire gauge amperage rating for that type of wire. You can transmit power, and if you do it, you should double it up. Like, don't use one strand to transmit power, use two. Also use more than one strand for ground. We'll wire up some examples and I'll show you. Ribbon cable is great for interconnecting two parts or circuit boards. You don't really want to use it so much for power, but it's great for signaling. So in this example, we're going to hook up ribbon cable to a header so it can be plugged into another board. So I'm going to start by using this header here. It's a 8-way 2x4, 8 total connections. I'm going to connect it into its header for starters because that's usually the best way to do it. And I'll put it in these helping hands like that. I'm going to pre-tin, again, always pre-tin. Pre-tin the connections. And I guess tin is appropriate because solder is tin. Tin and lead-free solder is tin and silver. Okay. See how I just make sure these all have some solder on them? Okay. Now using my knife, I'm going to cut my ribbon cable like this. Now we've cut our 8 connections we need. Now there's kind of a proper sequence that you use when you're hooking up ribbon cables to headers like this. We go down, up, down, up, down, up, down, up. So those are bottom 4 and our top 4. I'm going to strip these with my teeth. Now my method, I either start in the center or in the ends. I'm going to start in the ends for this one. So I'm going to pull those center ones back and start with the 2 ends. So I'm just going to touch it and then heat it up, and since both pieces have been pre-tinned, the solder flows together well. Now I'm going to do the other side. Now the reason I started on the ends and not in the middle or go down the line is because if you go down the line, they might, get crooked as they go along. But if you start on either end and attach those, it kind of lines up everything else to it. Now I'm going to want my tweezers. Attach that one. And attach this one. Now, if you want to make sure they're in place, once you have all of them in place, if you add some solder to one, you're only going to, only one will become disconnected. So if you want to add a little bit more solder, double check your connections, now's the time. See how that one's loose, but I can just tilt it back down and resolder it. Okay. Now I flip it over and do the other side. All right. Now I will snip off the pieces we don't need. Ah, my finger. Then let's say this is our motherboard. And then another thing I like to do when I put these headers in place, or any integrated circuit or socket, is just get one on the end. And again, I've kind of run out of hands here, so I'm having to bring the solder to it. Okay. Once you get a connection on either side or either end, it'll stay in place. Then you can, go hands-free and do it the rest of the way. The next type of wiring we're going to cover are USB cables. They'll work as a good example for multiple types of cables we come across, but of course USB is very common. So in USB you have 4 connections: power, ground, and data positive and negative, which is a twisted pair differential signaling. And the cable here, you see there's a metal stranded shield around it, which prevents noise from getting in. Then there's another shield inside of that, which is plastic, and then the 4 wires. So we're going to talk about how to attach a USB cable to a USB plug, and then also attaching a USB cable to another cable if you need to rewire or extend something. All right, so this is a typical USB type A jack. Type A means it's the large type. Jack means it's what the plug plugs into. Plug into jack. So I have a reference over here on my wall of what the pins are. USB is positive 5 volts, data positive, data negative, and ground. And the data signals are differential signals. Basically, one's higher than the other or lower than the other, and that's how it sets the bits. So as long as you have it written down and you get the numbers right, you'll be fine. I'm going to mark the ground pin with a black marker. That way I know the rest. So it's ground, data positive, data negative, positive 5 volts. So let's say we were needing to hook up a standard USB wire like this to this plug. So let's see, we don't have that. Okay, let's start from scratch, like that. So I'll take my cutters, remove the plastic. There we go. Reveal the shielding. Okay, now I'm gonna do this. I'm gonna take the shielding aside like this. Now there's a secondary kind of a plastic shielding here. I'm gonna pull that away and it will reveal my 4 colors of wire. All right, this we can cut. Now I'm gonna take the shielding and again, twist everything together. The shielding is going to be the same thing as ground, even though it's a separate connection. All right. See how these 2 colors, the green and white, are twisted together, twisted pair. We'll have a twisted pair connection in the, what is it? In the HDMI connection, and you also see it in Ethernet and pretty much everything nowadays, because everything nowadays is LVDS, low voltage differential signaling. And what that is there's 2 wires, and instead of the wires going fully high or fully low, they just differ from each other, like which one is higher or lower. And the fact that they don't have to completely go to a higher low state allows them to switch in a much higher frequency, which gives us the modern fast data rates that we're used to. All right, so I've tinned those connections. Okay, so in this guy here, bring him up. And I'm going to want to pre-tin these connections. So the moral of the story is pre-tin everything. Now this USB port is designed for surface mount, but we can make it work. Okay. Straighten these out a little bit. Okay, so again, we know where black and ground goes. I'm going to start with those, just like we did in the other header. These wires are probably longer than they need to be, but whatever. Okay, connect you. Isn't it cool? A little too much exposed on this red one. Okay, now our twisted pair. White's near the red and green's near the black. So I'm gonna twist them like that. The white one is next to red. All right, so those are 4 connections. Now here's our shielding. So we'll get a little wire. Here's our shielding. We'll get a little solder on the end of that. And then we can basically just hit anywhere. Just don't get the tabs because then it won't connect properly. There we go. You just need to look up the USB pins. There's only a couple of them. Wire it carefully, make sure everything's solid, and be sure to connect your shielding to the shield. I mean, you've probably seen us do this on the show before, but any shield or on any jack is always ground. So when in doubt, connect your shielding wires to the shields of a jack. Now I'm going to attach a USB cable to a USB cable. In case you had to extend or fix something, this is how you would do it. This is crazy. Here's my USB cable, so fix it maybe. Put that part on first. So we're just gonna do it wire by wire. And this is a great place to use heat shrink tubing because it'll keep it nice and neat. It'll look professional. So I'm going to slip on some heat shrink tubing and then attach these wires one by one. And I'm just going to basically heat them up and put them side by side and let them attach. Then we just do the rest of them down the line. Now we're connecting the shields together. Now we slide the large heat shrink tubing over the whole thing. All right, an interconnected USB cable. Now it's super long. Apparently there's a controller at the end of it. So there you have it. We covered several types of wiring. Now wiring is very useful for your own projects obviously, but the main thing you need to keep in mind is you can always rewire things. You know, don't be afraid if you have to cut a cable. Use some of these techniques to reattach them, extend them, and then using things like heat shrink tubing, you can still have a neat looking job that won't have, you know, short circuits in it. And even higher speed stuff like USB or DVI or HDMI, it can be done. It's just about taking your time and making sure the connections are nice and neat. Today's viewer question comes from Diago, who asks, is it possible to make an adapter to connect a keyboard and mouse to an Xbox 360? Yes, it is possible. I've experimented with this in the past. But what you need to do is emulate the controller itself, otherwise the system won't accept it. There are some commercial products and adapters out there that achieve this function. You would probably save a lot of time by buying those instead of trying to build it yourself. That's all the time we have for today. In our next episode, we're going to build an awesome portable device using the Raspberry Pi. We'll see you then. Stay tuned at element14.com/TBHS, where you can join the discussion, suggest builds for the show, and even have a chance to win upcoming builds. Remember, you can always email build ideas to benheck@element14.com. Thanks for watching.